lesson, we looked at a model of a line displaying data and helping us predict points. So this time we're actually going to look at creating that line ourselves. And one way to do that is to use a dry piece of pasta or spaghetti. So if you have this at your house, this is really helpful to kind of help you see where a good line would go. If you don't have this, you can always use the edge of a paper or a ruler, but this is nice because it kind of stays straight, but you can also move it around in case you mess up. You can see where you should draw your line. So if I were to tell you that this line right here represented that data, you would laugh at me because it doesn't go through any of those points. Or if I told you this one, because it's not slanted the same way that the data is. So what we're looking for is we're trying to draw a line or create a line that covers as many of the points as possible with a few points below and a few points above. It might go through some of the points, it might not, it could be okay. But we just want to try to get a good estimate of our values and kind of see that trend. So one way to do that is just kind of estimate, and then you can take a ruler and you could trace and you could draw that line. Another way is to kind of visualize like a little cloud around all these points. This will help you. You want to try to put your spaghetti or your line of best fit, which is what it's called, right in the middle of that cloud. So where there's about as much space in the cloud above and is about as much space in the cloud below. So right there would be a pretty good line of best fit. And so I went ahead and drew my own over here. And you'll see that that's pretty much where I drew that line. And we call that a line of best fit because it best fits the data that we're given. Let's look at another example. So in this example, it's a little bit more spaced out, but we can kind of see that trend as the X values are increasing. Those Y values are also going up and increasing. So if we took our spaghetti, we can kind of estimate where it would be. I would say that this is a bad line of best fit because it doesn't fit the data very well. This would be bad because it's facing the wrong direction. So it's somewhere like this, and we want to kind of put it in the middle. Remember, it doesn't have to go through any of the points. It's just trying to estimate them the best. You can also draw a little blob and try to fit the blob like I did here. So I drew a little blob kind of around all my points, and then I tried to draw it through the middle so that up here, this area up here is pretty close to this area down here. Vocabulary you'll want to know is overestimate and underestimate. So you see all these points that are above this line here. We say that the line of best fit underestimates those points because they're higher. So you can see this point actually ended up being higher, but it was estimated to be somewhere down here. This point is higher, but it was estimated to be somewhere here. The points down at the bottom are actually overestimated by the line. So this line is saying that these points should be up here. They're actually down here. So a linear association, so there's a relationship that's linear when we see that the variables kind of fall into a line. They're not going to be a perfect line, but when they kind of fall into a line. And specifically in this example, we would call this one a positive association, because what's happening is as the height of your dog increases in this case, the weight on average is also increasing. So you see that height increasing, that weight increasing, and you kind of see that line. It looks like almost like it's going up. It's increasing. It's got that positive slope. For this example, though, we call this one a negative association because you see as the weight is going up, so the weight's increasing. In this case, the fuel efficiency of these cars is actually decreasing. So when these two things are doing the opposite of each other, we call that a negative association. And you can kind of see the slope of that line is negative, and it looks like it's kind of going down. So you call that a negative association. Determine if these have positive or negative slopes if I were to draw my line of best fit. So if I took the spaghetti again and estimated that line of best fit, I want to know if it would be positive, negative, or 0. So this one here, you can kind of see that it's going down, it's decreasing. So as X goes up, Y goes down. So as we go to the right, our points are going down. So this would be negative. For B over here, it's a little more scattered out, but that's okay. You can kind of see as we move to the right, our points are going up. So as X increases, Y also increases, so that's positive. In this case, again, notice now we've got some negative values for the Y values, and that's fine. Still are just looking at the trend of our data, and you can kind of see as we go to the right, as X goes up, Y is actually going down. So this one again is also negative. Now over here, if we tried to estimate a line of best fit, it might look something like that, but actually a line is not a very good fit for this. So we would say that this doesn't have a very good association, because as X increases, Y isn't specifically going up, it's kind of scattered all over the place. So that one, we're going to just say that a linear function doesn't really fit very well for that one. In this last example, you see that most of your data is up here. It's slightly going up, so not a whole lot, but slightly increasing. And then you do have this point down here that we call an outlier, and that's fine. It doesn't have to affect our data very much. So don't let it kind of skew your data and pull it down here or your line of best fit. Kind of fit your line of best fit still to the most or the cluster of your data, and you could have an outlier over here, and that's okay. So this one is also, as you go to the right, you're going up, so this one is positive. So in the same way we talk about our slopes, we could also talk about the association. So the ones that have negative slopes also have negative associations. Positive slopes also have positive associations. No association would be something like this, where there isn't really an increase or a decrease. It's kind of just all over the